in search of a strong unconscious signal, blindsight and attention. Now we see why subliminal priming studies are really tricky to interpret. When the relevant stimuli are unconscious, the effects are expected to be small. Often they don't replicate so well. Maybe they just need a lot of power to replicate, but that means we need to test many subjects, and in science, resources aren't unlimited. For example, in an area of research sometimes called social cognition, there are findings like these. When we are primed with the concept of old people, we walk slower. When we are primed with our country's flag or symbols, we become more patriotic, even though we don't know that it happens. Now, often these primes are not truly unconscious, not in the sense that we do not experience seeing them at all. But we may not be aware of the relevance of these primes. Sometimes we say such priming is implicit. People did not pay much attention to the primes in these studies. Problem is, these effects may depend a lot on the person. So the variability is high. And so we may need a high N, that is, a large number of subjects, to detect and replicate these effects. As we speak, we are still figuring out how robust these effects are. Sometimes they replicate, sometimes they don't. It may take a long while for us to figure out. Back to our topic of priming of higher cognitive functions, rather than social phenomena, we have a similar issue. Because unconscious perceptual signals are typically small, we expect the effects they cause to be small. When we see a null result, we don't know what to make of it. When we see a positive result, we aren't sure if they will replicate. And even if they do, the globalists may say this is not really a challenge to their views. Just like the insect that can still move around a little bit after its legs are damaged, it's not that surprising that higher cognitive functions can be triggered by unconscious stimuli just a little bit. Maybe consciousness is needed for these functions to work normally at 100%, so we are really stuck. But here's the silver lining. Do unconscious perceptual signals really always have to be small? In class B.5, we already discussed how we may get out of this signal strength confound. In blindsight, we can have an unconscious perceptual signal that seems pretty strong. At least the subject seemed able to guess what the identity of the stimulus was pretty well. Sometimes, even within the same subject, we can present a consciously perceived but degraded signal at the same strength to the unaffected visual field. Then we can compare what may be the functions of consciousness by comparing a consciously perceived stimulus versus a stimulus presented to the blind field without this signal strength confound. Bob Kentridge and colleagues have done exactly that on patient GY. This was the same patient whose fMRI study we talked about in class B.5. Recall that in patient GY, only the right visual field was subjectively blind. So they presented a cue stimulus, presented consciously in the center, to tell the subject where the subsequent target stimulus was likely to appear. The target was a bar that was either horizontal or vertical. Because it was always presented to GY's blind field, a sound was presented too, to indicate that the target was presented, in case he missed them. The sounds prompted GY to press keys to decide whether the target was a horizontal or vertical bar. Turns out, when the cue was predictive of the location of the target, it helped the patient GY to respond more quickly, even when the target was in the blind field. This is what we call a cueing effect, measured in terms of a benefit in reaction times. Most importantly, the effect was not small. It benefited GY by over 100 milliseconds, which is to say, when comparing trials with a cue that correctly predicted the location of the subsequent target versus trials with a cue that wasn't predictive, GY was able to respond over 100 milliseconds faster. This was true, even though GY never consciously saw the target. So, in a sense, GY was able to attend to his blind field. And most importantly, this effect of the endogenous orienting of attention was similar to the magnitude of typical cueing effects for consciously perceived stimuli. A 100 millisecond benefit is a rather large cueing effect.